All right, let's talk about parallel and perpendicular lines. So we can see a red and blue line there that are parallel. The definition is lines are parallel if they don't ever intersect. They'll go on forever and never intersect. And we can observe and probably also know that the slopes of parallel lines are the same, right? So we can see in the box at the bottom, two lines are parallel if they don't intersect, the slopes are the same, and if we have two equations, they're parallel if m1 equals m2. Perpendicular is a little more interesting. Two lines are perpendicular if they intersect at a right angle. So we can see the red and blue lines there do that. And maybe you remember the relationship of their slopes. They are negative reciprocals of each other, right? So if you have if you have a slope of m2, you get by changing the sign and taking the reciprocal of the slope. So if you had a slope of 1/2, the negative reciprocal of that would be negative 2/1, or just 2, right? If you had a slope of 1/7, or let's see, 3/7, the negative reciprocal would be negative 7/3. So let's identify just from some equations what lines that are parallel and perpendicular. So think for just a minute, which of these are going to be parallel and which will be perpendicular. So they're all in slope-intercept form, which makes it very handy because we can just see what the slopes are. Let's see, these two, f of x and j of x, both have slopes of 2. And this is 1/2, negative 2. Those are negative reciprocals of each other. So the h and g must be perpendicular. Let's take a look. F and J, let's see, F is the orange and J is the green. Sure enough, those are parallel. And then here's H and here's G. They are perpendicular. Okay, so let's move to just do some examples. All right, let's find a line parallel to this graph that passes through this point 3, 0. Well, we know our new, let's call it g of x, it's parallel, so we know its slope is going to be the same, right? It's going to have slope 3, but we don't know what the y-intercept is. What do we do next? Well, we plug in these values. Our y value is 0. Our x value is 3. Excuse me. So 0 equals 9 plus b, so negative 9 equals b, and our equation will be y equals 3x minus 9, or we could write it g of x equals 3x minus 9. Okay? Parallel's pretty straightforward. What about perpendicular? Let's find another example here. Find the equation of a line perpendicular to 3x plus 3 that passes through that same point. 3, 0. Okay, well, let's call this function again. Let's call it g of x. And what is its slope going to be? Well, this slope, they tell us, is 3. So our slope of our perpendicular line is going to be negative 1/3, right? We change the sign and flip the slope. So this is 3/1. This becomes 1/3. How do we find our b value? Same way. We got to plug in 0 and 3. So our output is 0. We plug in 3. We get 0 equals negative 1 plus b. 1 equals b. And the equation of our line is negative 1/3 x plus 1. Okay? So this b value is different, right? This b value is 3. This one is 1. You have to plug in the point. Many students just say, oh, well, the b value is 3. It is not. Like, it's a different line, right? And here's what the equation looks, here's what the graph of that looks like. Oh, wait. Those are different equations. Okay, never mind. Ignore that. Okay. Let's do another one. Find the equation of a line that passes through the points negative 2, 6 and 4/5. Find the equation of a perpendicular line that passes through that same point. Okay, well, this is a little bit harder because we can't just look and say, oh, the slope of the new line is going to be this, because we don't know what the slope of our original line is, right? So we got to find the slope of our original line. So our original slope is going to be 5 minus 6 over 4 minus negative 2. So that's negative 1 over 4 plus 2 is 6. So our original slope was 1/6. Okay. So what's our new slope going to be? Well, we could write it. Our new line is going to have the equation y equals mx plus b. Our new slope is going to be positive 6 over 1, or just 6. How do we find this b value? We plug in the point that it's going to pass through. Okay, so we plug this in, 5 in for y and 4 in for x. We get 5 equals 24 plus b. We subtract 24 and we get negative 19 equals b. So our full equation will be y equals 6x minus 19. So the two steps are, we have to find the slope, and then we have to find what b is. Before, finding the slope was easy. Here, it took a little bit more work. Okay. All right, let's, so now let's, instead of just parallel and perpendicular lines, what if we want to find the intersection of 2 points, of 2 lines? Y equals, we want to find the intersection of this h of t and j of t. They're both lines. We could graph them and look at what they are. Look at where they intersect. We could also set them equal to each other. 3t minus 4 equals 5 minus t. Right? If we set them equal to each other, that'll tell us the t value where they intersect. So let's solve this. We'll add t to both sides and subtract 4 from both sides. We have to add 4 to both sides. Don't be sloppy. Okay, and we get that t equals 9/4. What does that mean? That means when t equals 9/4, these are equal, but we want to find the point of intersection. How do we find the point of intersection? Well, we could plug this into either of these two equations. Let's plug it into this one because it looks easier. J of 9/4 is going to be 5 minus 9/4. So let's see, that would be 20 minus 9, so that's going to be 11/4 is the y value. So the point where they intersect is 9/4, comma, 11/4. Okay? So there can be word problems that are a little bit interesting, a little more challenging. Let's look at this. A company sells sports helmets. So they incur a one-time fixed cost of $250,000, and each helmet costs $120 to produce, and they sell it for $140. So let's do this step by step. The first thing they want us to do is find the cost function to produce X helmets in dollars. Well, we did one of these already, right? It's going to be the cost per helmet, which is $120 times X, plus their fixed cost of $250,000. They already spent it. So that's their cost to produce X helmets. What's going to be the revenue function? Revenue means the amount of money that comes in. Well, we sell them for $140. So I think it's going to be $140 times the number of helmets that we sell. Okay. Now, in part C, they ask us to find the break-even point, which means the point of intersection of the two graphs. This is important if you ever start a business, right? How many helmets are you going to have to sell to break even? Okay, before you can start making a profit, right? Because you had to pay a whole bunch of money to start, and then you have to pay money every time you make a helmet. How many do you have to sell before you break even and start making money? Well, let's do the same thing. Let's set these equal to each other. Okay, so now we solve for x. So we'll bring x to the other side. We get $250,000 equals 20x, right? So let's divide both by 20. Let's see, how good is my mental math? So that's going to be 12500 equals x. What does that mean? Well, x is the number of helmets. So we have to sell 12,500 helmets before we even break even. So that's kind of a lot, right? I mean, if we're going to sell them at a little roadside stand in Rifle, Colorado, probably not great. If they're going to be sold in Walmarts around the world, then yeah, you're probably going to sell 12,000. Okay, but that's an important number to know what the break-even point is. So that's an application of linear functions. All right, good luck on the assignment. Let me know if you have any questions.